Hello students, I am very honored to be sending you this video about my profession and how it relates to chemistry. I'm Dr. Amanda Boston. I'm a professor at Lubbock Christian University and I teach organic chemistry. So my profession obviously relates to chemistry very closely. I chose this career because in high school I fell in love with chemistry. My high school chemistry teacher was amazing and I just fell in love with it, and I knew that whenever I went to college I wanted to major in chemistry. And then when I got to college I took organic chemistry, which is the chemistry, the study of carbon-based compounds, so any kind of chemical that's carbon-based, including like your pharmaceuticals, ibuprofen, Tylenol, like any of that stuff, that's all carbon-based. And so the reactions that it takes to make those chemicals is all organic chemistry. And whenever I took that class, I just fell in love with it. And then I knew I wanted to go and get my doctorate, and I wanted it to be in organic chemistry. I had thought that hi. Sorry, someone came into my office. So where was I? Oh, I had thought that I wanted to work for a pharmaceutical company and do research and development and like make drugs for a pharmaceutical company, not like in Breaking Bad. And so I wanted to go to graduate school and get my either a master's or doctorate, and I went to graduate school and I got to be a teaching assistant. So that's something whenever you go to one of the larger universities, sometimes they'll have graduate students who are teaching the undergrads. Undergrad is what you go to right after high school and get your bachelor's degree, and if you want to continue going, then you can get your master's or doctorate in graduate school. And so I was a teaching assistant, and I taught the undergraduate organic chemistry labs, and I fell in love with teaching. I didn't really think I would want to be a professor necessarily until I ran into someone. I came to LCU for my undergraduate degree, and I ran into someone from LCU, and they said, "You need to come back and teach at LCU." And so it planted that seed that teaching was a real possibility for me. And I just love working with the students and that aspect of it. It's like a mixture of some of my favorite things, like chemistry and people. It's like the perfect thing. So I was able, after I earned my doctorate, to get a job at Texas Tech first. I was an instructor, and then I now am a professor at LCU, and I love it. This is my 9th year here, and it's been pretty awesome. So the education requirements for this job, if you want to be a professor, then you would need to get some graduate level work. In order to teach at the undergraduate level, you have to have either a master's or a doctoral degree. You have to get that advanced degree. But like if you wanted to teach in high school, you would need the bachelor's degree, not necessarily a master's or a doctorate. So it is less schooling if you taught in high school or middle school or whatever. And I think like that just comes down to the passion for learning, because graduate school is hard. I've had several students who have come through LCU, gotten their bachelor's degree, and really were successful. And then once they got to graduate school, it was very, very hard. Even like top of their class people who've never struggled, graduate school can really break you down. It's almost like they should get in trouble for hazing sometimes, I think, but it's all right. It's just, it takes a lot of persistence, and you have to really want to do it. So other ways that I use chemistry in my field, well, I teach chemistry. So that question is what Mrs. Brown had sent on, but it reminds me when I was in middle school, one of my classmates asked the math teacher, "Do you ever use this stuff?" And she was like, "Yes, every day. I teach it." So like for me, I use chemistry all day, every day. But it is everywhere. It's not just in the classroom. And I try to make that connection for my students. So, and even at the beginning of this video, I was talking about ibuprofen and Tylenol. I used to be a pharmacy technician. Whenever I was 18, I worked in a pharmacy and like counted pills and stuff. I wasn't the pharmacist, obviously, but I noticed then that if you get a prescription for like Tylenol with codeine, the way that they abbreviate Tylenol is APAP, APAP. And that never made sense to me because I knew that the generic name for Tylenol was acetaminophen. And so, like, where do they get all the P's? Like APAP, acetaminophen, it doesn't really make sense. It's from, and I just, like, okay, so I worked in the pharmacy 18 years ago. I got my doctorate 10 years ago in organic chemistry. And like 3 days ago, I realized what the APAP stands for. And it's the chemical name, it's not the generic name. So whenever you see like acetaminophen, that's not the standard chemical name. There's a way to standardize name chemicals, and that's where the APAP comes from. It's in acetyl para amino phenol. So the acetyl and then the para and then the amino and the phenol. That's the APAP for acetaminophen. So that's, I mean, it's everywhere, even if you don't realize it. I was looking outside and seeing the colors change on the leaves. And then I was thinking about what I know about chemistry and colors coming from the chemicals, and how as the chlorophyll breaks down, that changes the structures of the chemicals that makes the leaves have their color. And that's why the leaves change color. Like, it's just really cool to see how chemistry is all around us. And it's something that people sometimes ignore because they just don't even know what to think about with it, but it is everywhere. And I love trying to make that connection for my students. It's not just something that I put on the whiteboard and that they have to write on paper. It's real and it's everywhere. What do I love most about my job? I really love the people. So whenever I was thinking I wanted to go into research and development for a pharmaceutical company, I mean, that was like undergraduate and grad school, and I was working in a lab and doing research in the lab, and I really liked doing that, but the part that was missing is the people interactions. And so the professor job is perfect for me because I love working with students and trying to figure out different ways to explain a difficult concept so that it clicks for them. I'd rather my students understand what's going on than try to memorize it and then just forget it. So that's what I really love about my career is the people, getting to work with the students. And I mean, I have so many students come into my office and like just pour their hearts out to me. And I feel really privileged to have the opportunity to have that kind of relationship with my students where they might tell me something that they haven't shared with anybody else, a struggle that they have. And I can try to give them advice or encouragement or whatever support they need in that moment. And I love it. I love it. It's so good. And I think that that's what has helped me be successful in my career is that this job really lines up with my passions. And I love chemistry. I love people. I love relationships, and I get the best of all those worlds in this position as a professor here. What piece of advice would I give you all, students who are graduating from high school soon? Are you going to go into the workforce, into college? I think that my piece of advice is like, any choice you make right now isn't set in stone, right? Like, because I work at a university, I do deal with the students who come straight out of high school and then they don't know what they want to major in, or they start out one path and they're like, I really don't like this. I don't want to go to medical school, but everybody in my family is saying I need to go to medical school. It's okay to change your mind. And as you're starting to move on and become an adult, like, you have to make your own decisions. You have to figure out what you want to do. And it might not line up with what your family is wanting you to do. And that's okay. I mean, I could go on and on, but that's all that I'm going to say about that. Just really think about what you want to do and start to be an advocate for yourself, because if you're not going to do it, then nobody else will. I have some quotes on my board I want to show you. So up there, you might not be able to see them, but the top one right here says, what you focus on grows. And then the light blue one, that's the one I really want to point out. It says, you don't get anything without asking for it. So if you, if there's something that you want to go after, if you don't know something or whatever, like ask people questions and don't be afraid to ask questions. You're not going to get anything if you don't ask for it, right? And sometimes you just don't know what to ask about. So find someone in wherever you're going, into the workforce and the university or whatever, find someone who's there and knows what you don't know, so that if you run into any issues or you have any questions, you can ask them for help. So there was one more thing I wanted to show all of you. Let me share my screen. This goes along with what part of my favorite stuff of my job is. I made these videos last spring that were in response to all of us being at home from the pandemic. So I just really loved doing this for my students, trying to bring chemistry in an entertaining way and an educational way for my students. So this one, let me find, you can do this, it's called the Cartesian diver. It helps describe the ideal gas laws, PV equals nRT. Whenever you increase pressure, that decreases volume, and so it made the Cartesian diver sink. Yeah, this one was a fun one. I was showing how to use a spectroscope. Oh! So that was fun. And then these were really fun. So I am a big nerd, and this was a full lab experiment for my organic chemistry students. And I was making aspirin here, which is something they would have done in the lab. That's an experiment they would have done, but because we were all at home. So I filmed myself doing it, and then I posted this for them to watch. But I had to make it entertaining, right? So this is themed after Mr. Rogers' Neighborhood, and it's my laboratory. And that's all. That's LCU campus, isn't it beautiful? It should take us, oh, it's going to show us the link. Hold on. So this part's not as exciting, but still, like, I filmed myself doing the experiment, and hopefully it was entertaining. Okay, so oh, this was soap. This wasn't aspirin. So this one was like the real, my piece de resistance. I really had fun making this. It was Olaf's chemiluminescent adventure. So I framed this as Olaf was coming to visit me, and then I was teaching him about how chemicals can glow. It's chemiluminescence. And then we did some glowing. We synthesized the chemicals that like help. It's a glow stick reaction is really what it is. And Olaf was with me like the whole time. And then I ended it with a music video, which was totally awesome. And this was right after Frozen 2 came out. So, I mean, it was current at that time. So this is where it turns into the music video. And I dance around and do all kinds of stuff. And then, oh, at the end, Olaf melts. I know, you'll probably think that it's dumb, but I really enjoyed doing that and wanted to give something to my students that was entertaining in a time of unknown situations. So I hope that you all enjoy your chemistry up to this point, and no matter what you go into, maybe you have some knowledge of how chemistry is involved in every aspect of life, even if it isn't 100% noticeable. So thank you, Mrs. Brown, for letting me do this, and I hope maybe I'll see some of you all at LCU in a future academic year. Thank you.